ALTRA, Innovating with Impact. This is a presentation we prepared for our PFAS session today. Uh, of course, I need to say a word about ALTRA. ALTRA is about dealing with environmental liabilities management and nature preservation, water resources management, and circular economy growth and climate change mitigation and adaptation. We're really into the big game of changing the world, as was said in the introduction. Our purpose is to build resilient societies by solving major environmental challenges, the challenges that our planet is facing. Our ambition is to collaborate with iconic world class organizations to tackle those broad environmental challenges, which I believe, and our company, our corporation believe, are the most challenging humanity has ever faced. Our impact. We've been around for 40 years this winter. We did more than 7,000 remediation projects. The value of those projects exceed $3.5 billion worth of environmental field work. Over the years, we treated millions of tons of impacted soil with hydrocarbons, with metals, all sorts of contamination. And in the recent years, we've focused more on water treatment. We so far dealt with 12 billion liters of highly contaminated water treatment, whether it's PFAS, whether it's dioxin and furanes, PCBs. We're really into the niched, very tough water to treat. And we also have other technologies, which will not be the topic of this talk, but just to give you a flavor of the combination of what ALTRA has to offer in terms of technologies. We deal with water solutions, so PFAS is the main one, but we also have dredging and dewatering, biosolid management, water main renewal with the lining technology that enables to renew from within without digging streets, water mains, potable drinking water mains. And we did a lot of it, more than 2,500 kilometers so far. And of course, site remediation, like I said. Now, about PFAS. We've been working on PFAS for quite a while. We were founded 40 years ago, like I said, but I traced back our first projects on PFAS on the AFFF spills, where we were treating AFFF, aqueous film forming foam, on a military base in Canada. We did that first project in 2001. And at that time, we were using a rudimentary, a non-sophisticated version of foam fractionation or froth flotation, if you like. Moving back, closer to us, 2013 is a year where in Quebec, my province in Canada, there was a terrible accident. A train derailed with 52 rail cars full of light bitumen that derailed and exploded, caused a lot of casualties in that small town, 47 of them. And of course, the fire had to be put out. And we used close to 9,000 gallons of concentrated military grade and industrial grade AFFF to combat that fire. Lots of water was used to do that. The water was pumped back to the wastewater treatment station of the city, and our company was there to treat that water. We were there. This happened in July that year, and we stopped around Christmas time at the end of the year. And we learned a lot of things, became aware of how important, how toxic, how dangerous this challenge was. And then we started on a journey for understanding what worked in our treatment and what didn't work as well. We worked with the prominent universities in Montreal to work on this problem, McGill and University of Montreal. And then we found solutions to deal with highly contaminated PFAS streams, which led us to have our first pilots in 2019, then our first on-site demonstration in 2020 on military sites and landfill sites. And then we did several projects in Canada and the US. Forgot to mention, we're based in Quebec, Canada. And then first execution of a contract as clean water as a service on a PFAS impacted leachate from landfill sites in the US. I'll talk about that in a moment. What's our approach? Well, not going into the details because of time, but PFAS are produced at PFAS producing plants or used in PFAS in those plants. And they end up in wastewater streams and other types of wastes, which end up to landfills. Those landfills have leachates, and then they end up to wastewater treatment plant. And this eventually goes to surface water or groundwater, etc. And treating PFAS at the end of that spectrum in the river, for example, in this slide, costs a ton of money. It's highly diluted and becomes very difficult to tackle. On the other hand, if you capture it at the plant, at the effluent, where the flow is quite small actually, but the concentrations are hundreds of thousands, if not millions of part per trillion, or at the landfill, then you have a chance of making a cost effective and efficient treatment. And that's what we do. The same examples goes to biosolids or to firefighting foams at the firefighting training area, for example. And so the idea is to deal with PFAS at sources. Michigan has led the way and has proven that this can be very effective as a method. And that prevents it from getting to food, drinking water, and so on. Our approach, well, like I said earlier, foam fractionation, we use a version where this technology, proprietary technology, is used in continuous mode, closed circuit. We recuperate all our gases. And the idea is to have a water column where you create bubbles in that water column. And if you're very effective at removing the driest foam of that column, and the PFAS tend to go at the interface of those bubbles, then you effectively remove PFAS from that water. Seems simple, not that simple, but still, it's extremely effective at removing long chain PFAS. And we're getting a lot of success with short chain PFAS, although this is a challenge. What you end up with, a concentrate or a foamate of PFAS, probably concentrated by a factor of 1,000,000, and the volume reduces by probably a factor of 1,000. And then you've got the treated water. In most cases, you don't need to go to a media, but you could, and I understand there will be some presentation about that. It can be cumbersome and expensive to use those media, but if you were successful at removing most of the PFAS upstream, then it becomes doable. We have our own media, but we could use carbon or resins. And this is the Minnesota site. It's a landfill from Waste Connections. It's been announced publicly. And the New York site will be announced shortly. Both are signed. We're commercial on both sides, and we're installed in Minnesota. We're treating about 100,000 gallons per day at that site. And what are the facts? What have we learned from those treatments? After having treated millions of gallons in the last 12 months, first lesson, there's no wall-to-wall solution. No PFAS stream are the same, especially at high concentrations. And the co-contaminations, the other substances in the water have a terrific effect on the treatment. So no PFAS are alike, really. In landfill sites, amazingly, short chain account for the majority of the PFAS that we find. This tells us two things. First, it's going to be a challenge to treat them, but most importantly, there's a transformation that happens in those landfills. Long chains are either fixed or transforming, and probably through biotransformation. And there's a lot of fundamental research on that topic. I'm a PhD, but I'm not in fundamental research anymore. But this is very, very interesting going forward. Long chain PFAS out of a foam fractionation treatment can be removed quite efficiently. We've got results 99.999% removal on most long chain PFAS. Sometimes we use surfactants and other additives, but it works very nicely. For short chain PFAS, it depends on the species. Some, for example, recently got PFAS BS results as good as 75% removal, but not all the time. So it really depends. Sometimes we're not satisfied with the results we got. And PFBA remains a very tough nut to crack. We don't have great results for PFBA. Fortunately enough, it's one of the least toxic PFAS there is. And so it's less of a problem. But definitely more research is needed on that topic. What's our model? Well, we come to the market with a clean water as a service business model. We do in-house treatability study. We have our own labs. We work with the best universities in the world. That enables to tailor solutions. And then those solutions are asset built into our units. We will invest, build, operate those units. We will guarantee the treatment. We will come to an agreement with the client on what is a success, and we won't be paid if we don't meet that success. And that's what we've done with Waste Connection in Minnesota. So, in a nutshell, we design, build, operate, finance, and guarantee the treatment. So that's our key PFAS differentiator: low investment cost, highly customized approach, safe approach. I didn't emphasize earlier because of time, but since we're in closed loop, we're recuperating all of the gases. That means that there are no air emissions or no water droplets emissions from these systems. That's key because foam fractionation in batch mode requires transfer from vessels to vessels, vacuum, venting, and the permits for those vents on landfill sites are extremely difficult to get. And the last thing our customers need is us fooling around with their permit. That I was told that very clearly. It's the most robust solution, and we're willing to guarantee it. Operator friendly design, completely automatized. It's great to be here again, Walid. Thank you for the opportunity, and wish you all the best.
Thank you for sponsoring this session also. So I have a question. I love the business model, like how we take the whole ownership from design up to execution and investment even. How is it perceived by clients? Because we still have sometimes old mindsets where they just want to buy an equipment. They don't
Okay.
understand service.
Yeah, a very good question, and we ask ourselves that question a lot. The simple answer is that, of course, some operators will want to operate their systems, but this is not simple operation, and it's not core business. And actually, we're trying to make the case that this is noise to their operation. And when we do pilots with them, they kind of get it. So it worked with Waste Connections. It's working with other companies. We'll go public eventually. The fact that we're willing to guarantee the treatment, not being paid, and even pay penalties if we don't do it, is also showing some commitment, which skin in the game, like they say. Yeah.
Yeah. I have one, we can take one question. I have a question from Katsunobu Ihara. What kind of method are you using to measure PFAS concentration?
Uh, the EPA method that are recommended right now, because of the type of PFAS streams I've shown in this presentation, we're using EPA 1633 in the lab. We're not an accredited lab, but we're benchmarking all the time our results with the accredited labs. We've got the same kind of limit of detections and same quality of analysis, and we use an LCMS state of the art equipment to do that.